So we start with the afternoon session, and before we start with the big data afternoon, I've just an announcement to do. This evening, or after the big data session at 5:30, we will have an additional new presentation on the new manual on business demography, and the paper will be done by Tammy, Statistics Canada, and Norbert Reiner. So we will finish probably not at 5:30, but more 6 o'clock or even later. Okay, so back to the big data and back to Diego Kuonen. Professor Dr. Diego Kuonen is currently professor of data science at the Geneva School of Economics and Management at the University of Geneva, and founding director of the new Master of Science in Business Analytics at the same school in Geneva. 2001, he founded Statu Consulting and regularly consults on applying statistical thinking to big data analytics for business and government bodies in Switzerland and across Europe. Currently, he is also the principal scientific and strategic big data analytics and data science advisor and consultant for the Directorate, the Board of Management, and the New Data Sources Working Group at the Swiss Federal Statistical Office. Professor Diego Kuonen is ranked within several global big data and data science top 100 influencers list, and he is very, very, very active on Twitter. So, Diego, please, the floor is yours.
Thanks, organizers. Thanks, Claude, for the invitation. So, I will not tweet. So those who follow me, I could tweet my main messages. Those who already follow, you already have an idea what could be the main messages. And I think my presentation nicely links with what I saw this morning from Irene with this data virtualization. But I would say it's a little bit, it's not science fiction I'm speaking about here, or what I try to give you an idea about this thing called analytics of things. But it is reality, maybe not in official statistics, but for example, in manufacturing, things like this, I'm speaking about this is real life. So this is real fact. And so the question is, I like to address here, are production processes of official statistics? So I come back to this towards the end. And analytics processes, are they friends or are they foes? So this will be one of the big challenges. You already apparently had a wonderful keynote yesterday on how important is change management, transformation. And I think this will also be a big challenge official statistics is facing. Okay, so this is about my, you get the slides, you can read about my background. But basically in 2001, I created a company. I wanted to do analytics. Everybody told me you're crazy, there's no future. 17 years ago. Apparently now everybody wants to do it. And so I have quite a lot of real world experience, and I'm trying since several years to put it into place by doing a lot of strategic consultancy, as mentioned as the Swiss Statistical Office, but also on some project in the past from Eurostat about when they spoke about trusted smart statistics. So as mentioned, I'm one of these influencers. I think currently on big data I'm in position 26. But once again, this is not a scientific ranking, but it's just to show you there's a lot you can do for statistics, and I'm somebody who believes strongly in statistics, in official statistics, and this is a little bit the things I promote. So I'm a professional statistician, so just looking, I think we're in Switzerland, so I'm allowed to make this publicity here. So this is our most famous mountain we have, the Matterhorn. So what has this to do with this guy here who looks like my person and this thing here? So this looks like this classical normal distribution. This is me, some 3 years ago, and this is the mountain I saw when I was a baby. When a baby, I'm originally from Zermatt, so this is the village at the bottom of the Matterhorn. As a baby, I saw this. I'm still fascinated by it. Through education, it became this, and through real-world experience, I had to learn this thing here does not exist. So this is a meat. So this is also a little bit what I tried to do, is demystifying concepts. And now that's also a wonderful opportunity to give you here the keynote, introducing these new data sources, special sessions, by demystifying big data, how I see what big data is, what also is the problems, then the Internet of Things, then what is analytics about, and then by what I started, this thing called analytics of things, and what type of process models we have. So let me start with big data. A quote from former director of Eurostat, from Walter Rademacher, who said, just as haute cuisine must reinvent itself in order to stay at the forefront of gastronomy. So official statistic has also been confronted with this changing context and needs. For example, he mentioned as challenges the data revolution, the emergence of big data, and other challenges. But as you see here, it's about reinventing yourselves. It's about reinventing a profession. And this has to do, once again, with change. So you have to reinvent a culture. You have to wake up first the culture that some change is needed. So what is this hype about big data? So big data as a term itself is from 1997, and it has really become a religion. And there's no formal definition of big data. Also in the official statistics world community, nobody ever defined properly what the big data means for statistics. And so what basically it's about accumulation of data that cannot be processed or handled using traditional processes. So the key point here, it's about infrastructure, it's about architecture, it's about hardware, it's about software, point. And this is now also one of the biggest challenges, because infrastructure nowadays is there, hardware is there, software is there. But if you do not store or manage the data in a way that you can learn something from the data, then why you should store them? And this is now a little bit a big issue here in a lot of, because I'm mainly consulting also private sectors at the C-level, and they have IT infrastructure in place. There were no statisticians involved in defining the infrastructure, and now they have to do something with the data because everybody wants to do something with the data. The only thing you can do then is, with this data, you cannot do anything more than this. So ideally, in an ideal world, this architecture, the data management should be placed up in order to learn from data, to make sense out of this data. And this is what I call analytics. And the wish is then to make data-driven decision-making, or data-informed decision-making. It will still be, in most contexts, the humans who do decisions, and also data-informed policy-making. So it's really a little bit this infrastructure, this architecture bit. There's a definition over Wies. There's even a one page I found where you find 52 Wies for big data. So the classical one are the volumes. The volume, so we have number of observations, number of variables. The problem from a methodological point of view is not this here. This we can sample. The problem is it's not a homogeneous sample. The issue is if we have too many variables. This is volume. Then we have variety. This is really the idea. You have the different data sources where you take classical survey data, you take register data, you take this data, and then you take data from drones who are controlling enterprises or whatever, and you have to link these things together. As you all see from IT point of view, this can be quite easily solved by matching the different data sources. But you have to do it with statistical rigor and statistical principles. Then we have the velocity. This is really the speed of the data. The classical example is social media, but also in the manufacturing, where you have on a second wise, there's thousands of sensors who are giving you real-time data. You cannot store everything. So you have to decide what you store. Then you can say, okay, we store every 10 minutes something, but why 10? Is this representative of the underlying process? Then what you store, okay, we can sum up the numbers, the number of observations. If we divide one by another, we have an average. But is the average representative of what's going on? As you already see here, statistical principles are key. I'm not speaking about advanced statistical methodology, I'm speaking about standard statistical principles. But once again, these V can help you defining the infrastructure, the architecture. The most important V is the veracity. So the veracity is the trust in the data. It has to do with reliability, which is quality over time. If you use sensor data, then you don't have a signal. So what you do with this data? If you lose the connection to a satellite, what you do with this data? Capability, being able to correctly and in a precise way to measure things. If you want to use in the entrance of those sensors to count how many people go in and out, if this measurement system doesn't produce accurate, precise information, is not capable of measuring the thing he intends to do, then the veracity, the trust is not there, and also the validity of the data. And all this has to do, related to veracity, is the quality of the data. And now this is for me one of the USP of official statistics. You have quality frameworks in place for small data. Most industries, they don't have a clue about these. So it's about extending, augmenting the existing ones. If I speak in the private sector with companies and saying, yeah, but we need quality frameworks. You know what I do? I send them the one official statistics has agreed on the national level. And then even if your business is not official statistics, try to respect these, then at least you have a good idea what different types of quality dimensions we have. So the point I want to make here is really, this is the veracity. So this is really, for me, one of the key is veracity, and not of the outputs, only of the inputs of the data. And the thing is, this is nothing new about this. I think we already had this in official statistics, just thinking about the first censuses in the US, etc. All these were there. So what is new nowadays? New is a fifth V, which is the value. So it's really, there is usefulness of data. It's also called data monetization. Industry sees there is money in the data. So we need to make something with the data because this is value. We have in Switzerland a little bit politically minded party, Digital Switzerland. They came out with a digital manifesto in November 2016. Data is part of infrastructure of Switzerland, like road, railways, power networks, and government and economy has to generate value from this data. So data is infrastructure. And this is the fifth V, which is the value. So let me summarize the 5 V's of data or of big data. So we have volume, variety, velocity are from like the essential characteristics. The ones who qualify the use is veracity, then followed by value. You can have the best infrastructure, the best data management. If you do not trust in the data, good luck. If you never did something with the data, you will have a return on investment because you never did something. But if you want to really do it from a scientific point of view, then you have to have trust in your data. Or what I call in the data pedigree. So this is like the data which comes into the close. Trust is not sufficient because there also has to be some utility. So this is the value here. So these, for me, are the two key filters. And these two key filters you should think about before you invest in architecture. Finally, several weeks ago, beginning of September, there was a new strategy for Digital Switzerland from the Federal Council. And in it was written, so not in English, so it's my own translation. It's in French and in German. Data themselves are central raw material. So our Federal Council, so it's the top of the government, sees data as raw material. So this may be not the surprising thing, but what's now written here, this means that the data must be of high value, accessible, and trustworthy. So it's one of the first things I see in one of these government documents, the word of trust in data, now, so in Switzerland. So it's really now, this is the veracity. So this is the hype about big data. So let me give you the next one here, Internet of Things. So my coffee machine just unfollowed me. So if you understood this one, then you know what I mean by Internet of Things. The term is from 1999. This is like the new religion. Everything is smart now. And now even in Europe, you have smart statistics, everything has to be smart. Smart cities, smart rail, smart farming, smart agriculture, whatever you want. But the key point I would like to make is it's not about things, it's about data, point. Things is the output, what you can do with the data. It's about data and not things. And now just from an abstract point of view, think about, this is basically projecting this like your NSA, you take together from different business registers data. So you're already connected at some point. So even before this thing existed, you had it to solve issues of standardization and stuff like this. I just want to tell you there's nothing new here. It's just complexity increases. So IoT is about data, not things. So there's a lot of marketing. This is, for example, from Cisco, that in a smart city, a city of 1 million will generate 200 million gigabytes of data per day by 2020. So these are visions. The problem nowadays, and I'm coming back to this problem, there are no uniformly agreed standards about how these things communicate. As long as you go with the same manufacturer like Cisco or Microsoft or somebody else, then things work. If one day you take one of these things or smart meter from somebody else, then you have a problem of connection already. Because standardization currently is a big issue in this thing here. As it's about data, let me just apply what I showed you before. These are my 5 V's of IoT data. Once again, trust, veracity, and value are key here. If there's no trust, I don't know anybody if you will live in a smart city. If you do not think about trust, if there's no value, then it can work, but it can also not work. So let me go back a little bit some years ago. Edward Deming, who was a statistician, also very well known in official statistics, in 1942 wrote, the data are not taken for the museum. If you do not do anything with the data, why should you collect the data? Now just think about in your offices how many data is there you never learned out. I'm not speaking about smart city data or smart meter data, just the data you already have. The ultimate purpose of taking data is to provide a basis for action or a recommendation for action. And this is exactly the thing here. This is like my slogan, so data is like the fuel, and analytics, so this learning from data, this making sense out of this data, this will be the engine of this what's called data revolution or digital transformation. And just to be clear here, the challenge is not digital, technology is there. The challenge is transformation. So if it's this analytics, isn't this something we already did since hundreds of years? Could be. Depends on which approaches you consider. Basically, there are 2 approaches of doing analytics, is learning from data. There's this traditional approach. I think most of you, this is how your office was built up, how official statistics, how traditional statistics grew up. It's the analysis of primary data. So you had an idea in your head, you thought about the best data to confirm, to evaluate this idea. It's the same thing. My idea is, does it rain? Primary data collection, you open the window, you look in the sky, and you see there's no rain falling down. So I just disapprove, so I didn't confirm my idea. So this is primary analytics. By doing this, I use models. I need to understand why is it going on. What's key here from a paradigm, this is deductive reasoning because the idea was there first. All classical surveys are constructed exactly in the same way. So this is primary data collection. So you had 100% control about the data collection. This means an example where rain, I can say, okay, I do not trust here, maybe there's some strange, so I go out to the other door. I have control how the data were collected. But this is basically the playground of traditional statistics. Then, on the other hand, we have the secondary data, observational, convenience found, organic data. And they are there, but the collection is not under your control or under your supervision. So it's just typically register data is a classical example of secondary data. As long as you did not construct a register from scratch on your own. All external data sources are secondary data. And that's why we all have these problems of veracity now, because that's why we do not trust the data, because most of them are secondary administrative data. And if you learn from this data, we're doing basically what's called data science nowadays, which is a new word for data mining. By coincidence, it was termed in 1997 by a statistician. And the idea is to create new ideas. By doing this, we do what's called predictive analytics. And these are, if you want, the criticized black boxes. These are the best models we can use to do predictive analytics to generate the ideas. Generating ideas is not the same as explaining an idea. And this is a key paradigm shift also for statisticians. This is, for example, where all machine learning falls in, etc. So it's about generating ideas, and this is basically what's called inductive reasoning. If I retake the example from before, does it rain outside? I could go downstairs -2, you take your smartphone, you take an app from a meteo, from a weather service, you have 100% trust in this data, and you make the decision based on this. And this is basically inductive reasoning. Artificial intelligence has nothing to do with intelligence, they learn inductively by analyzing data. So this is the most hyped example currently. So these learning machines based on parametric nonlinear statistical models, so machine learning models, they do inductive learning. But it's clear if you would like to succeed, you need both. You have, like, once again, inductive is data first. So by induction, you have a data, you generate idea, and what typically you should do, you should check to try to confirm, to validate this idea. For this, you need primary data. By doing this, you collect initial data on everything, and continuously you try to improve, you try to knowing better and better your underlying process on which you want to base a statistic on. So this is really inductive, deductive, going up and down. And this is basically, if you start doing this, you do it in a scientific way. And statistics helps you, the traditional statistics, for the deduction step. What's also here, basically, this is continuous improvement. These are not old, new ideas. This is from George Box from 1976. That's why it's just the quality a little bit strange. The thing is, this was written in the Journal of American Statistics. No, I think nobody except statistical nerds at the time read this journal. But this is exactly currently what's key. This is this inductive, deductive reasoning cycle. John Tukey put it in the other way in 1980. Neither exploratory or confirmatory analytics is sufficient. If you replace one by another, this is madness. We need both of them. This also means there will always be classical surveys to confirm ideas, but maybe only on a population you identified as having a potential to contain the answer over there, using inductive approaches. Now, this is like if you start doing this, you want to continuously improve. In a world where you continuously improve, you would like to solve problems, but I always have to tell people problems do not exist. There's an opportunity to improve. So just take this in your mind, then you want to continuously become better and better. I have to reinforce this because at the end you see why it's important. Now let me demystify this analytics of things. So what has this to do now? Now Internet of Things, big data, now we have analytics of things. And the thing here is now the following. This will no longer be scalable, etc. To take all the data of the census back to your office, to do the data cleaning there, and then produce fancy statistics. This world one day will be finished. So we have to go with the models We have to go with the data quality frameworks to the devices or close to the endpoints. Show you here an example and then I'll come back. So classical ways, you have a centralized data set. And then here you have different things. So this is now a little bit, you have planes, etc. But you can have different ways where you take out your edges. The classical way, you put everything to the central one, everything is done clean up here, everything works. But now if you start putting in also a lot of things, say from drones or satellites, things like this will not be scalable, this will not work. Here's for example an example where you have wind turbines. What does it have if you don't have a connection to the wind turbines? What does happening to the wind? Nothing will happen. So the idea is now you bring the analytics to the edges. So that's why it's called edge analytics, or close to the endpoint with so-called gateways. So execute analytics, so this learning from data, and this also means, and this is for me key, also the data quality processes on the gathering devices themselves. So at the edge or at the endpoint or close to the origin data source as possible. This is what's called analytics at the edge analytics. This means you have a distributed IT architecture layer called edge computing. Here the example I told you, most efficient way to control data quality is at the point where the data were created. If you already see, for example, at this point there is an issue here, you can make the data correction here. There's no need to take all the data here as long as this is working correctly. Just think about this idea, how this could influence all other statistics. Household statistics, for example. You could think about, as I said, to produce, you manufacture your own smart meters, so you have 100% control about the data collection. You put this in every household, and if you want an update, the only thing you have to ask the device is something new, yes or no. So there's maybe even not be a data transfer from the household back to the NSA, except change yes or no. The only change could be one more child or something like this. If you go this, you have scalability. If you go this, you have issues then also, I will go back about security. You can solve privacy issues, because within each endpoint, you can have 100% privacy. You can also the anonymization frameworks, etc. So the idea is here really to add this analytics layer. So in 2 sentences is about moving analytics and the frameworks to the data. Those who Google a little bit analytics of things, you will see basically the same message, but not the data quality frameworks. This is apparently all people who work in this seem to forget about data quality, because this is on the input side, and this you cannot make films or you cannot make movies, so people prefer to show movies on the output side. This is also something I think official statistics has to work on. It's not only about disseminating the produced output, but also about communicating the beauty of the input with the data quality framework. If you want to do this, it has to be centralized management of analytics. So analytics at the heart is basically an algorithm, which is a model. Now it's not only about monitoring data, it will be also about monitoring algorithms. This could be that for this business at time, I don't know, on September 25 at 2 o'clock, the best algorithm is this one. And this algorithm will go on until there's a problem, and there will be some pre-trained algorithm somewhere. If this one goes wrong, the next one comes in. So just think about it. It's not just about monitoring data. Data quality is about monitoring algorithms. This means there has to be rule development, what's called maintenance, version managing, etc. Now you may see this guy here, this professor is crazy. These things exist as products, as technology. If you have enough money, you can buy this in with gateways, full-fledged provided by companies like Dell, Microsoft, with edge analytics, everything included. And then you can really then do this. So security will certainly be improved because you will reduce the complexity. Privacy, The sensitive data we retain on the edge. You never take it back. You need to have an analytics governance. Maybe it's less strong governance, and you can be very transparent. A lot of people think applying machine learning algorithm is not transparent. Who said this? Nobody. You have to be transparent if you go with this algorithm, because something happens, goes out. You have to be transparent, has to be reproducible, etc. This you can also do with black boxes. And reliability, scalability of the edge devices, and trust also. Because by explaining this, you create trust, public trust, because they do not see you take all data, and they also see they can participate in this new ecosystem. What current challenge is here, there are no standards for IoT data and analytics. I call them localized standards, so it's global and local. Local, for example, we have Switzerland, you have the Swiss way to do it, and global maybe it's then European or even the bigger way. So there are different ideas how to do it, how to differ terms, so no standards here. The currently standardizations effort are needed. Could this be done by official statistics? And question I'm asking here. By augmenting existing ones, because you already have some type of standards which allow you to communicate. Could this be a future role of official statistician to put in place these standards? Finally, also these are not new ideas in the sense, this is from the UN Statistical Commission in the 47th session in March 2016 on big data, methodology and estimation. So the first one, big data needs official statistics as much as official statistics need big data. Okay, this is a very important key. But the last one is my favorite one. The method or algorithm can be applied at the location of the data source. So it's not me who wrote this. This was wrote in December 2015. Oh, it's you. It was you, yeah. That's why that's... Okay. So we have now here still the author, so that's great. He still believes in it. No. Okay. So let me give you some key messages here, then showing you the processes. So we have this, the veracity of data is more important than ever. So this is input, throughput, output. Or I could say this is the data veracity, so you have to really have trust in these data. Perfect data do not exist. Perfectly imputed data do not exist. So you should have sufficiently trust in order to put them here and to produce them. And key is here the data veracity. Analytics is aid to thinking, not a replacement for it. It's about complementing, augmenting official statistics. And you will see later on then by a presentation from Bertrand Lazare from the Federal Office of Statistics. This also has to tackle from a strategic point of view. You cannot come and do big data, now let's do some fun here. For 4 years we have money. There has to be a strategic thinking approach, because it's not about taking your current production, you say, okay, it's no longer valid, new version. It's about augmenting, complementing the existing one. So finds way in the existing production where it makes sense to do these things. So it's about augmenting the strength of humans at the end to become more powerful. There are a lot of offices that do routinizable jobs. So this can be nowadays automated, and they have resources, more power to do other things. So it's not about making the Robocop here. It's about this Robostat here. You see, he's not normal. Now you have this one here. And he's augmented by this analytics, becomes more powerful. He's a little bit a different type of official statistician. So there's something new coming in. So it's really about creating these Robostats. What's clear is that you cannot solve problems by using the same kind of thinking you used when you created them. There needs to be a change of thinking. Also, what has to be clear, it's not about technology. Even what I'm speaking here, it's about the process. It's about the cycle. It's interdisciplinary, transdisciplinary team effort. But there we have the problem now, because not only in the official, also in the private sector, most companies are organized in this way. Everybody does his work in his silo. And so this is now something which has implications all over. So analytics is a cycle process. So if it's a already Deming told us, if you cannot describe what you're doing as a process, you do not know what you're doing. And this is process thinking, which is currently missing a lot of people. Now let me go a little bit back. You want to continuously improve. The most classic, the most well-known process model is the PDCA cycle, which was proposed by Shepard in the 20s. Deming then popularized it. Plan, do, check, act. I think everybody already heard about this. This is continuously improved. What's key here is it's a never-ending circle. At one day you need to stop because you have to go back to your family or whatever, but it goes on like this. Okay, now, so you also see quality is never an accident, it's always a result of intelligence effort because you want to continuously improve. Now let me show you this one here. Let's take the production process of visual statistics. The version 5.0, I think now soon will be a 5.1. This is seen in a cyclic way. This is completely consistent with this PDCA cycle from Deming. How many of you saw this, know it in this way? How many know it in this format? Most of you know it in this format. So where is the cycle? So the cycle disappeared. And this is now the human bias which comes in, as it sees it as a sequential process. I know inside we do turns and it's things like this, but the cycle is completely away. There's no feedback which goes here at the beginning or whatever. So this is one of the key frameworks for the modernization of official statistics and also standardization. Do not take me wrong, standardization is needed. But over-standardization is dangerous nowadays. So where is the continuous improvement cycle? So it's really if you go from here to here, this at some point was lost. It's clear if you read the documentation, it's written, but just as a visual, the cycle is away. Moreover, there are other points. This I found recently in a statistical journal of the International Association of Official Statistics by David Marker. The author believes that the reason operational costs of this process has not been a central focus is a difference between NSA focus on measuring quality of the products rather than continuous improvement of the quality. So once again, there should be a move from measuring quality to improving quality. Looking at a lot of data quality frameworks is about measuring things. You have all KPIs, indicators, you measure things. It's clear at the heart there is this improvement, but there needs to be more on this. The other thing here, it's fully deductive reasoning. Specify needs, idea, build, collect, data collection. So this basically is 100% deductive reasoning. Idea first, then data, then collect data, etc. So the big question is now, if this is fully for deductive reasoning, it's fully sequential. I know that at the heart, it's not sequential. But even if like this, it's step by step. Okay? And also what's going on here, the evaluation, just take me, I find this wonderful. I just want to prepare you. The evaluation is just done at the end. Nowadays, you can evaluate everything with data. So there's this evaluation at the end. So let me just take the point. So it's not really suited for this inductive reasoning when we already have secondary data. The evaluation is only performed at the end. So it needs to be not thrown away. It needs to be augmented, complemented. It needs to be adapted in order to incorporate analytics and both approaches, inductive, deductive reasoning. An example could be data-informed continuous evaluation at any step. Each time something is changed, you collect data and you verify with data whether it makes sense, this change or not. This means the production needs to be augmented and empowered by analytics, version 1.0, version 4.0, with analytics of things, because there's another complexities which is coming. So this is for the production. Now I go another process model for analytics. If you forget about production, You go in a world where you do analytics, then you have also process models. So this is one of the well-known ones, cross-industry standard process from '96. It's fully consistent with the PDCA. Problem understanding, so business understanding, data understanding. If data is not good, change the question. Already you see here it goes to the left and to the right. Then preparation, modeling, depending on which algorithm, evaluation, deployment. There's continuous monitoring of data, and there's this continuous wish to improve. Now it's clear, standardization here is very difficult because this is how to create these ideas. So, because it's about developing these analytical assets, so this is exactly the same as before, this is the CRISP. Once you have enough trust in the results, in the ideas, you start standardizing, you start putting into a deployment. So you publish it here in the system, in the production, someone integrate in the application, you test, produce, continuously improve, you monitor that everything going fine. By doing this, you get new data, and now I think if you see what design is about, you have now an infinity sign going. So it's very philosophical, but it's about development, analytics, and what's key here, it's not sequential, it's completely iterative. And if you take a new generation who get a data, they want to learn something for the data, use processes like this. Because in this world, you do not know in advance which statistical method should be used. I don't know. I have data. I know I have this, I use this software, and the software are these 2,000 models. I'll try them all. I'll use the best one. Just think about how you do it in a classical product. The model is fixed, and then you get the data. So it's a completely different way of seeing things. So the thing is here now, how to put both together. And the key to success is to make sure that the beginning and the ending steps are well thought out. So the beginning is really also to do with the data, and the ending when you link both words. So we have on one hand the current statistical production here in this example, and now we have this analytics process model. Now the question, how do we link them? We cannot use this process for doing this. We cannot use this one for doing this. But we need one as a basis for the other one. It's about augmenting, complementing this one. So here, for example, in this I showed you there's a point here, embed insights. And now the thing is, embedding insights, then it's not fixed. It has to be continuously monitored what you embedded here. If something wrong, one has to interact with the process. So it's a big question. We don't have solutions how to do it, but it's completely different process model. I'm not speaking about architecture, technology underlying. It's just a way of doing things. How sees it Eurostat? With the trusted smart statistics, like analytics of things version 1.0 for official statistics. They have it with trusted smart statistics with the slogan push computation out. So this is a little bit what Eurostat now pushes with trusted smart statistics, that computation is put out. Basically, this is the initial idea of this edge analytics of things. So we don't have the solution, but we have the chance with Bertolozzo, who speak after, my person for the teachings in Bucharest. We write a paper on ideas how you could possibly merge both processes. And there's no solution, so I don't expect now Google it how to do it, but a little bit more insights on what I presented you today. So I don't know what the future is and how it looks like. Nowadays, if you become very rich from a money point of view, then you have to foresee the futures, whether robots will come or not. Then you have visibility, then people invite you. But I will not do this. I'm not a future telling. But what I can tell you, as soon as it works, what I explained to you, no one will call it production process of official statistics empowered by analytics and augmented by analytics of things anymore. So this is a little bit, one day it will work, and it has to work in this way. Nobody will call it in this way. But this is really to make it clear The word empowerment is for me key here. It's about augmenting, complementing the existing one. What's clear, however, is, as Deming told us already in 82, the transformation can only be accomplished by man, not by hardware. Computers, gadgets, automation, new machinery. A company cannot buy its way into quality. So the transformation has to be accomplished by man. Or in the words of Mark Twain, the only person who likes to change is a wet baby. This is a little bit the reality. Maybe there are not enough wet babies in official statistics in certain countries. As long as there are not wet babies, why should they change? It's the same, I have 3 small boys. The smallest one, he will not change directly. Maybe after several hours, he will come. Also, he wants a change. So everybody at some point is about changing. Or the other thing, if there's no pain, no change. But if it's not, I prefer the only person who likes to change is a wet baby. So here's my Twitter handle, so you can also connect me on LinkedIn. So I hope I was too criticizing things going on. Maybe also with respect to new data sources, just have in mind it does not mean it cannot be your data you already have. This could also be a new data source. So thanks for your attention.
Thank you very much, Diego, for this excellent presentation. We have time for 1 or 2 questions before we move to the session, the big data session. No question? Yes. Oh, Netherlands, please.
What kind of role do you see for business registers in this big data field of analytics of things?
Maybe. So I see a key role because it has to do with the provenance of the data, basically. These registers do not exist since 2 years. So there's a lot of human brain already there. Also with respect to data quality and stuff like this. And this is a USP which they currently have. And also think what comes in place is the standardizations who are already in place. This is something a lot of industries you start this now, they do not have it, except because there's no commonly agreed standards and stuff like this. There's a huge potential, also in official as general, but there has to be a switch of mindset to going from the output, because the input, the USP is on the input side. And not what you can do everything with the registers, on what, speaking about the veracity of the register, also respect to make long-term statistics and stuff like this. So I see a huge potential, but then it has, at some point, more marketing needs to be done.
Yes.
Thank you, Diego. Again, very interesting, and a topic I'm very interested in, also currently working on. I had a question on the cycle with intermediate analytics, and I actually was thinking, I thought that in the Netherlands they were using the quality gates. I'm not sure if you're familiar with that kind of analysis. So that at certain kinds of the production process, they have quality gates. Is that a little bit what you intend, that you during the process you have these quality gates and then improve the process or stop the process if things go wrong?
Yeah. This could be a first step where you really start linking both worlds. And I can just see for experience, the problem is now people do not, they think with this you can do everything. And I think in the Netherlands, they know this is not for everything. That's why I have other processes as well. And also other countries, they try to find links some point to link both to show basically the added value of something like this as well. And I think this one for me will be a key point, because there's no solution how to put both together. So what a lot of countries do, they separate both worlds completely. For example, this is the classic of experimental statistics, a lot of in the ESNet big data projects. There was never an idea to augment, complement the existing production. So this problem was solved by definition. But now, for example, in a new strand which comes in at the European level with the big data thing, they identified 2 or 3 projects where now they make some of feasibility studies, how to link things like tourist statistics, I know, one on job vacancies and stuff like that. So this you have really from me, it's also from a strategical point of view. That's why what we in Switzerland try to do a little bit better, because I think you will hear it afterwards from Bertrand Lazon. This is the projects we are running. The goal is to augment existing production. So there was already a will to have this gate somewhere. There's no solution that it will work, but at least there's a will from a strategic point of view to use this gate to link both worlds.
UK.
Thank you. I have a small technical question. On one of your slides, you referred to the concept of a zettabyte. I was wondering what a zettabyte was, and I was also asking the question, if Z is the last letter of the alphabet, is that the end of big data expansion after that? Do we come to a stop?
No, there are IOTAs, and I think Zeta is an old concept. They come constantly in new names. No. But there will be no end. The problem is, after what I told you, I'm an external. What I missed something in the past in official statistics, but try to define what big data is. And big data is everything, basically. It could have been a role of statistics 10 years ago to say big data for official statistics is this. And everybody agrees. Does this things people think with standardization? Then everybody knows what it is. This question about is it large enough, is it small or big? For me, it's a question of veracity of trust. And nowadays, there are a lot of statistics coming back with more methodological link to your answer to your question. There's a lot of methodological work which is done now. If you take from Harvard, for example, if you take, I don't know exactly the numbers, but if you take 1 million data file of size 1 million, if you get just 100 high-quality primary data, you will have a better answer than with secondary data. There's a lot of methodological work because the statistical academic community also are waking up a little bit.
Last question.
Thank you for a very interesting presentation. You mentioned that we should push, the analytics or the quality to the edge. So often, the big data is in the hands of collaborative platforms, for example. So how do you see, how could we push the analytics and the quality to the edge in these cases?
Yeah. There will be a problem about win-win. Why should give an external you the data? So you have to offer them something. And what is your USP? You can show them what is the data quality framework. Just thinking like that. So it could be in return that he gives access to your data. You help him to improve his data quality framework. So you would have a win-win situation for both parties. Because I don't think why a telecom operator, except you force him by law, for example, Switzerland should give to the Swiss Federal Office data on the mobile data. Why should they? So, yeah. And the second point is you could think about sending them, you don't need to send me your data, but I can send you an algorithm like a script. You pass it over your data, and you just send me back the output. And there maybe you can put in things like this.
Okay, thank you very much, Diego. We stop here. And we start with the next session. Ronald, please.
Is there a mouse? Yes, I think so. Yes. And
All right, we're going to,
yes.
after this inspiring keynote, we continue with big data in session 5. Title of session 5 is New Data Sources. We have in total 5 presentations. If you've seen in the agenda, it's split up in 2 times an hour. Probably take a little bit more for the first part because there will be 3 presentations and then 2 presentations after the coffee break. The first 3, I switched it a little bit in the program because I wanted to keep the country presentations together, because all 3 of the country presentations will show you the use of big data in the production processes. I also would like to have a discussion at the end, so I will continue with, so we'll have the presentations, the first 3, and then have a general discussions for all 3 panelists. So I'll try to keep them up here. The first speaker, no, I wanted actually, and I know Steen is ready to go. I wanted to say 2 words, and he's going to sit down. 2 words, why big data is become a big deal in official statistics. From our perspective at the UN, it started around 2013, 2014, and it was already driven by the fact that we would get this agenda on sustainable development. So in advance of the agenda actually being accepted, this 2030 agenda with the sustainable development goals and the targets, which was accepted in or adopted at the UN in September 2015. In advance of that, people were already worried about how can we monitor a very large agenda, how much data do we actually need for that. So they were talking at that point about this data revolution. You had the data revolution report that was done in November 2014. And at the UN we had a few things. If you wanted to look into a little bit the background of this, I would recommend go to the Statistical Commission documents in 2015. There's a document about data revolution at the Statistical Commission. There was a document about this UN Global Working Group on Big Data, which had run its first year. And there is a document about transformative agenda. Now, the transformative agenda, and I think is one thing that we, it was mentioned by Diego at the end, is that it's not only about the data, it's also about change of culture in a statistical organization. So this change management, it's not only chain management, but also change management. And I think this transformative agenda indicates that there are a number of things also on the human resources side that we need to think of. So that's how I bring it to the statistical community, the big data. But now I will give the word to those who are doing the actual work on this. And I would like to first get the view from Statistics Denmark. So Steen Jørgensen, the title is New Data Sources and What We Do in Denmark. So yes. Let's see.
Yes, thank you.
15 minutes.
15 minutes.
And
you have used 3.3 minutes of my time, I can see that. But okay, thank you. First of all, thank you to Diego for his presentation. It's almost the same. I don't know what I should say now, but I will try also to talk about Internet of Data and not things. And on the web page on Wiesbaden, you can see it has new data, so big data, new data sources. And here is only new data sources. I don't know the definition of big data, and I understand why now. We are talking about new data where we are definitely most